Hey everybody, this is Larry. This is day 9? Yep, of the Leetcode March Challenge. It's almost been a year. It's been a year since pandemic, so it's kind of been crazy times. Hope everyone's doing okay, staying alive, staying, healthy and stuff like that. Hit the like button, hit the subscribe button, join me on Discord, ask me questions, check it out, and let's answer today's question. Add one row to tree. I do these live, so if it's a little bit slow, feel free to fast forward and all that stuff. Okay, so what is this for? You have a value and you have to add a row of nodes with value at the given depth D. What does that mean? 4 2 6 1 1. This seems like just a way like you have to do rows. So but what does that mean, right? Like you want to add a value 1 in depth 2, okay. How do we decide where the 2 and the 6 goes? That's what I'm trying to figure out. Add 1 to depth 3, 1, 2, 3. So add 1 here and then there. Okay. But is there more formal definition? Okay. Given a create 2 subtrees, no original left subtree but a left. Okay. So basically you just kind of push it out. The left will be on the left, right on the right. So this is going to be, I guess you can do it in a number of ways, but I'm just going to do it recursively. Yeah, and once you get to the depth, or depth plus 1 or depth minus 1, something like that, then you just push things out and you just add the nodes. I don't think there's anything that tricky. The only thing that may be a little tricky is that the examples that they give you may lead you to think that you only have to do it once, but you have to do a you have to go through the entire tree. Pre-order or post-order doesn't really matter because it only triggers for one level anyway, right? So yeah, so I think this becomes an implementation problem once you've realized that this is a tree, and you can't really do better than it's not quite linear, but it's worst case linear. You have to go through the depth of the tree. It's up to O of D because you could terminate early, but we'll analyze that in a little bit. But we know that in the worst case it's going to be linear, and that's good enough for us to start implementing in terms of for competitive. For interview purposes, you may talk a little bit more about the analysis before you code. But yeah, I'm going to call it pre-order. Yeah, pre-order. Why not? We'll look at the node probably, and then we'll look at the current depth. I always, yeah. I think this is a little bit weird notation, but that's because I use the other style for variable names. But yeah, and then basically if node is none, then we just return because nothing to be done. If current depth is equal to D, then this is where the magic begins. It could be D minus 1. I have to make sure, and this is what testing is for, and also maybe just, to be honest, thinking of a little bit. And if you're in an environment where this is production, technically you probably actually should put, this is very easy to prescribe to TDD, and what I mean by that is test-driven dev. And what I mean by that is just at least one component of it, which is to write the test first. And once you have the test, then you can just test this, and you play around with it, and you don't have to worry about off by 1 as much, as long as you know all the things that you're testing. In this case, it should be okay. Yeah. Okay, so current depth is equal to D. What do we do? Or D minus 1. We could fix that easily. So when I'm programming, I also keep these things in mind. I'm very mindful of where I can possibly have off by 1s, so that if I do have issues, I'll come back later, right? And in another meta level, I would also think about, okay, if I am off by 1, what would the output look like versus the projected output, right? Like if we add, if we add it to depth equals 2 instead of 3, then then it would look similar, just at one level lower, right? If it doesn't, then it means that we are wrong in other places. So yeah, also want to make sure that okay, okay, this may be off by 1. So yeah, so basically we want to say, let's see, right? So this node, we want to move the node, so we want to create 2 new nodes. I think. So left node, left new node maybe, is equal to tree node with the YU. Right new node is equal to the same thing. And of course, we need two different objects, even though they have the same, they contain the same thing for now, but they won't in the future. So that's one thing to be mindful of as well. We do left dot node is equal to left new node, but not in that order. Left new node is equal to node dot left of this new node. And this is kind of like, you practice your linked list, then this should look familiar with respect to just like inserting a node into a linked list. Yeah, and then now we can return else, because we don't want to go any further. You don't actually need the links first to return, I think, because we just have an else here, but I like to do that sometimes depending on the context, just to be clear. Otherwise, then we want to go pre-order node.left, current depth +1, and pre-order node.right current depth +1. And again, I may be off by a little bit here because we want to maybe get the parent of that level, but it might also be 0 index. And I think maybe we can just think about it. So depth is 3, we want to go, this is 1, 2. So that means that will trigger at 2. And also there may be a case where if we yeah, we might have to, I don't know how that, you return the tree node is the root node, so we have to actually take care of the root node if depth is 1 or something, because this is 0 base. So then basically now we just we do a pre-order of the root, and let's see, is it 1 or 0? Because if this is 1, then so let's play around this. There is a case that we haven't considered in code. I mean, we thought about it, and that is the case where well, this is very funky. I don't even know how long this is because this answer just looks very weird, but it seems like on a cursory look we inserted one level lower. Yeah, it just seems like we entered one level lower, so that's fine. We could probably just change it to 0 to be clear. Or maybe just check that to n-1. And here, ooh, maybe the other way then. Whoops. So this is a little bit hacky. I recommend actually going through the code and doing it. But now we can kind of think about this case, and there's no easy way to copy paste this because I think it's an older problem, I guess. Yeah, and then the other one is, of course, if we want to change depth is equal to 0, then actually, do we want to put it in the left or? Oh, actually, they tell you how to do it, so I guess it's not that special of a case. I just didn't read it. If depth is 1, there's no depth. Then create a new node with and the original tree is the left. Okay, I just want, because I think the ambiguity is whether that should be on the left or on the right. But it seems like it is answered. Then yeah, new node is equal to tree node of re. New node dot left is equal to root, and then return new node. So I think this is good. Minus some typos, like we would have put in more test cases, and that should be good. Let me actually, because it's easier to change this one to depth of 1. So then we could get, in theory, we should add a 1 at the root, and it looks okay. So let's give it a submit. I think minus typos, this should be okay. Cool. Yeah, accepted. So what's the complexity, right? In the worst case, it's going to be linear because it's going to be O of n, because we have to look at each node once or something like that. And in terms of space, it's also kind of, people would usually say for a tree, for space, it's going to be O of h for the height of the tree, or, which is O of n in the worst case as well. However, in this case, you're also bound by d because you don't have to keep on recursion past the d step. So then your recursive stack will at most be d, right? And that's, even though we don't have to, you can think about this as a recursive stack where every core is going to create a new entry up to d or height, or yeah, depending on what bound you're using, it'll be d for the maximum height, the depth, or just O of h or O of n, because of the height of the tree could be a linked list essentially, and then you have to go through the entire list. But you try to make as tight as a bound as you can, and that, yeah, that's all I have for this problem. Let me know what you think. it's a fun practice. It's a combination of a linked list or a tree. Definitely recommend it. I guess we don't need it here. But yeah, you should be very comfortable with this if you're doing interviews and stuff like that. But yeah, that's all I have. Hope y'all have a great day. Yeah, almost middle of March. Stay in there, and we'll see you later. Take care, to good mental health, and see you tomorrow. Bye bye.